Hi, my name is Matt Scare. I'm a principal specialist solution architect for data warehousing here at AWS. Now that we're in the window for the end of support for various Netezza models, we thought this would be a good time to talk about migrating from Netezza to Amazon Redshift, the AWS native data warehousing service. We'll save plenty of time to answer questions at the end, but please don't hesitate to put your questions in the chat window as we go, and the team here will answer those questions as soon as possible. Let's start with the Netezza migration target, which is Amazon Redshift. We're processing in excess of 2 exabytes a day for more than 15,000 customers. We're investing in making Redshift faster and faster, further enhancing the value proposition for this managed service. And with the general availability of lake formation, having a data warehousing solution that integrates with your data lake has never been more important. On this slide, we see some of the Amazon Redshift customers. And why is this important? Having the largest number of cloud data warehousing customers and their clusters allows Redshift to gather lots of metadata about how the data warehousing service is being used, and we can use machine learning to optimize query performance and operations. Having Amazon.com running one of the largest data warehousing workloads in excess of 500 petabytes on Redshift allows us to harden the service and allows massive investment in the product. This also allows Redshift to benefit from the large ecosystem of ETL, BI, and system integrator partners, and provides access to a large number of people skilled in Redshift. And finally, lots of customers run their mission-critical workloads on Redshift, as you can see when you look in the Gartner and Forrester grids. On this tab, we talk about the speed of Redshift, which allows us to reduce the time to insight and provide better performance for your users. These claims are based on the industry standard TPC-DS and TPC-H benchmark. The Redshift team itself publishes the blogs with instructions for these data sets. The link in the bottom here is for the 3, 10, and 30 terabyte data sets. For Netezza customers, I think you'll find that Redshift is a cost-effective data warehousing solution. The Redshift billing is straightforward, and there are many cost control throttles to make sure that the cost is predictable and entirely in your control at all times. Also, there's only a single version of Redshift available with all of its full functionality. So all customers enjoy the benefits of, say, security without any additional cost. Now, if we look onto the integration with the data lake, Redshift is the only cloud data warehouse that integrates directly with S3. So you can run ad hoc queries on a serverless fleet on clusters that have their data residing on S3 and potentially joining it to Redshift data on the Redshift direct attached tables. The Redshift Spectrum, which we'll talk about later, reuses the glue and lake formation data catalog, providing the same view of data across Redshift Spectrum, Athena, and EMR. And finally, Redshift Spectrum now supports table and column level access control through lake formation. Okay, now if we look at the similarities between Redshift and Netezza, the differences are quite striking. Both have a shared Postgres lineage, and so queries that you've been writing on Netezza that say query the PG tables will also work on Redshift, and easing that transition there. You may find that if you're a Netezza expert, that you actually have quite a bit of Redshift expertise and you just didn't know it yet. Many of the concepts in Redshift should be familiar to the Netezza experts. And the architecture has many parallels to a pre-Spectrum Redshift, and we'll talk more about Spectrum later on, but there are some parallels that are quite striking. So now if we look at a graphic of the Redshift and Netezza architectures side by side, we can see that both have a concept of a single node that you connect to. On Netezza, it's a host, and on Redshift, it's the leader node. And then on the compute layer, you have the notion of SPUs on Netezza, and then the compute nodes on Redshift. So with that in mind, there are some very important features of what's available in Redshift that's different than what's available in Netezza. The first one, as alluded to earlier, is Redshift Spectrum. And this enables you to run Amazon Redshift SQL queries against exabytes of data on S3. With Redshift Spectrum, you can extend the analytic power of Amazon Redshift beyond the data stored on the local disks or to direct storage in your data warehouse to query vast amounts of unstructured data in your Amazon S3 data lake without having to load or transform any of the data. Redshift Spectrum applies sophisticated query optimization, scaling processing across thousands of nodes so the results are fast, even with large data sets and complex queries. And a great thing to notice with this is that the amount of compute that you have available on your Spectrum layer is approximately 10 times the compute power of your Redshift cluster. So it scales as you scale the cluster. The next important feature to consider that's unique to Redshift for folks moving from Netezza is the ability for Redshift to auto-scale with its concurrency scaling feature. With this new feature, Redshift automatically adds and removes capacity to handle unpredictable demand from thousands of concurrent users. Concurrency scaling comes at no cost to almost all customers and every customer, even with those spikiest workloads. During peak business hours, the Redshift cluster may receive a higher than average number of queries as business analysts start using their BI dashboards or start running long-running daily workloads which compete for resources. Customers could over-provision their clusters to meet the peak demand or schedule workloads to match the query throughput. However, concurrency scaling can handle this automatically for you. So with concurrency scaling, customers can support a virtually unlimited number of concurrent users and concurrent queries with consistently fast performance. When concurrency scaling is enabled, Amazon Redshift automatically adds additional cluster capacity when the customers need to process an increased concurrent read queries. Write queries are still processed on the main cluster, however. So concurrency scaling is now used by many of our customers, and we've gotten positive feedback. For example, here's Yelp. Elastic resize is a new feature which enables scaling of Redshift up or down in minutes. When customers enable elastic resize, Redshift adds additional nodes to the main cluster and distributes data across the new configuration in minutes. This new feature is a significant improvement over the classic full resize offered by Redshift, in which Redshift would provision an entirely new cluster, which could potentially take hours. This will change the number of nodes in the cluster. So when you go from 3 to 6 nodes, for example, before we would have to redistribute all the data. With this, we can bring the additional 3 nodes that the customer requested in automatically. The resize operation takes a few minutes, and then the cluster becomes available. With elastic resize, customers can increase the size of the cluster's compute and storage easily and quickly process complex workloads to decrease the query response times as needed. Many Redshift customers have workloads which need additional compute and storage resources to meet their growing requirements or to meet a demanding workload. For example, an ETL workload for certain hours in a day or month-end reporting may need additional Redshift resources. Elastic resize will make resizing Redshift significantly faster, and customers can pick a resize option on the console or schedule a resize and let the Redshift handle the rest. So the next category of features that are new for Netezza customers when moving to Redshift would be around ease of use. The first one is for auto analyze, and this is where Amazon can automatically collect stats on the table in the background throughout the day. You still have the option to gather stats yourself if you want to, or you can just leave that for Redshift to do it. The next one is auto distribution, which is where Redshift will change the distribution as the characteristics of the tables change. And this works hand in hand with the Amazon Redshift Advisor, which we'll talk about later, which can also make distribution key recommendations based on the actual query patterns for the table. After that, we have auto vacuum delete. And this is where Redshift will be reclaiming space that's been marked for deletion when we do a logical delete on a row in a table. This happens once again in the background, but you still have the option to do it manually should you choose so. A new feature we launched earlier this year is auto workload management. This is where we have Redshift selecting the concurrency for you. So you don't have to pick the concurrency anymore, but you can make buckets of jobs that have different priorities. So it could be your ETL is a very high priority, but maybe intern jobs have a less high priority. And then Redshift will juggle the resources automatically in the background. The final two would be around scheduling snapshots. And this is where we would be, a lot of the automation that you may have to have written for yourself in the past can be handled automatically just through the console or through the Amazon command line interface. And then finally, Redshift's support for stored procedures will allow a migration of the Netezza stored procedures to Redshift. And this greatly reduces the amount of effort for a migration. So now we'll look at some of the common ground at the physical level. And so once again, as I mentioned earlier, you may have quite a bit of Redshift expertise and just not realized it yet if you're a Netezza expert. So when people talk about a leader node in Redshift, they would be talking about a similar construct would be a host on Netezza. Similarly, a SPU on Netezza would be analogous to a compute node on Redshift. And then the SPU contents would be somewhat similar to what the compute node would have. And then finally, users aren't going to be interacting directly with the SPUs in Netezza nor the compute nodes on Redshift. And so this will be very similar behavior. Okay, now if we look at the database level, there are also many areas of common ground here. Both Redshift and Netezza rely on the data being compressed and using zone maps to minimize I/O. And that compression is done at the column level. Data is distributed across the compute nodes, and so all the considerations that you would have in Netezza would be applicable on Redshift. In this case, on Netezza, the data can be distributed either by a key or random, and the analog on Redshift would be also a key or even. And Redshift would also contain the option of having an all distribution option, which is where the entire contents of the table are put on the first slice of each of the compute nodes, or the auto distribution style, which is where Redshift can figure this out, the distribution for you, and that would be net new. And then some of the MPP attributes such as no indexing, no partitioning, and no enforcement of the primary key would be consistent between the two databases. And both Netezza and Redshift employ a variety of caching strategies. If we continue on at the database level, we can see some other similarities that are common between the two databases. One is on the Netezza side, where you can have a column alias be referenced in the same select clause. On Redshift, that also exists. This is called a lateral column alias. And this can be really, really helpful when we've done migrations for customers. On Netezza, there's the notion of grooming a table to physically delete logically deleted rows. And this is just the vacuum delete on Redshift. And once again, this has now been automated. Now, on the Redshift side, you would have an identity column, and then Netezza, you'd have a sequence, and then we would have stored procedure support for both databases, and then the Schema Conversion tool, which we'll talk about in a few minutes, can automatically convert your Netezza stored procedures to Redshift SQL. The final two items are around workload management. So when we're on Netezza and we're talking about the prioritized query execution, this is really analogous to an auto workload management with query priorities on Redshift. So a lot of those lessons that you've leveraged or decisions you've made on your particular workload are likely to be quite applicable on the Redshift side. And then Netezza has a notion of a short query bias. On Redshift, we have a notion of short query acceleration, where Redshift will grab queries out of the queue that it thinks will run fast and run those in a separate queue of itself. And the final one on this list is the pace of innovation. So the rate of change in the roadmap might be quite startling if you're a Netezza customer right now. So a new version of Redshift is rolled out every 2 weeks, and it's a great opportunity to provide your feedback to your AWS account team for areas that we can improve on or opportunities that you see. This is a great way to have those potentially be placed on the roadmap for the future versions of Redshift. And then expanding out from Amazon Redshift, the AWS ecosystem for Netezza experts is wide open for areas of opportunity for this. So as we'll look at here in a few moments, we have a schema conversion category here that will automatically convert your Netezza DDL to Redshift DDL, including the stored procedures. This is also how we can do data movement for Netezza, and we'll get into a little bit of an example of that. And if you have a streaming or near real-time requirement, I recommend looking at the Kinesis Firehose service and/or leveraging the loading capabilities through Redshift Spectrum. You can also have Redshift be a source as a data source for machine learning, and Redshift can be a destination for DynamoDB. On the data visualization side, QuickSight is available and can crawl your Redshift cluster automatically. And so you don't have to really do any configuration at all. You can just point it at your Redshift cluster and then start dropping and dragging to build your reports. And on the monitoring and alerting, I recommend looking at CloudWatch. We have several dozen metrics that are available for Redshift to allow you to administer and to report on the behavior of the cluster as you go forward. For existing Netezza customers, your ETL and BI tools are likely to still be supported on Redshift. And so anything that can communicate via a JDBC or ODBC connection will likely just work with Redshift. We have strong relationships with leading ETL and BI vendors, and this has helped us to work on refining the SQL to make it as efficient as possible. Redshift is all about being more efficient versus just merely throwing more hardware at that. And we have a few examples here. So we have a Tableau white paper, which you can search for. This is on their website. Similarly, a MicroStrategy white paper. And then finally, on the AWS website, you can look at some of the Redshift quick starts. And from the link on this slide, these are some of the partners that are available to help you with Redshift. Now let's switch gears to the Amazon Schema Conversion tool. You often hear this referred to as SCT. And this is a tool that can help you both convert your DDL from Netezza to Redshift DDL, and it can also do the actual data movement. And we'll step through an example for this. Okay, so let's look at the example. So in this first case here, you can see the Netezza structure is on the left, and the table is described itself on the top there, and Redshift is on the right column with the table at the bottom. So this is just the setup here. The Schema Conversion tool itself is free and is available for download on the website. Now we have our options to do partitioning if we want to parallelize the data movement. So partitioning for partition tables are done automatically. However, Netezza doesn't have partitions, so we'll use virtual partitions. And there are three types for this. There's the list, range, and then auto split. The example here, we're just going to use a range partition on the PK column. So you can see the layout of the different partitions. And now we'll move to the next slide here. We're looking at the Agents tab. So now we would be ready to actually start doing the data movement. So here are the tasks. So we can look at these the three phases of the task. There's the extract, the upload, and then finally the copy to Redshift. There's one process per virtual partition, so enabling massively parallel execution. The extract step is pulling data from Netezza, which is now behind the scenes using the Netezza external tables for additional performance. On this slide, notice the pipelining of the tasks. We're not waiting for the previous task to complete before kicking off the next step in the process. This step is the extractor, is the data being pulled from Netezza and sending it to S3. Performance here is principally a function of the network performance between the on-prem data center and AWS. And now we've moved into the final step, which is the copy step, where we're actually loading the Redshift cluster from the data that we landed on S3. You can see both the previous steps are still underway while we've initiated a copy. There's no one in here. We're just waiting. We're watching it process along. And then finally, the task is completed. So this is how easy it can be to set up actual table migration. So we use the Schema Conversion tool to convert the DDL, and then we use the extractor to extract and then automatically load the Redshift target. So there are several ways to perform a database migration. A must-have requirement is minimizing the downtime. The image here, which we'll build up, will summarize how you can plan a data warehouse migration with minimum downtime. You can achieve this by running 2 systems at a time, but a major challenge is to keep the data updated in both systems, capturing a change on the source and then applying them to the destination during the migration. In general, data warehouse jobs tend to be long-running ETL processes and load update data in batches, typically on a batch basis, of course. To simplify the migration, you can simply configure and run your ETL jobs to run in parallel on both systems until the cutover, and that eliminates the requirement for CDC. So we'll just step back through here. So here's where we're doing our audits. We've been running this in parallel for a while. We're proving that the data is correct on the new system. And this is that option, as we've mentioned, of having a dual target ETL. This is the step as we just did with the walkthrough on the Schema Conversion tool, where you may do a one-time bulk copy. That example we did was completed in less than a minute, and it was 350 million rows. It's just part of the setup where we have to optionally modify the ETL to point to both targets. And then finally, we're at the beginning here. This is actually pulled from one of our AWS blogs that talk about a Netezza to Redshift migration with 0 time, and we have the link here at the end of our slides. Here are some of the additional resources. So you can try it for yourself. Here's a link to Redshift, and you can try it out. The next part there is a whole section of quick starts to jumpstart your planning for how to do this. The third one here is the blog I mentioned, which is Netezza to Redshift without any downtime. We also have a blog entry here on using the Schema Conversion tool. A bit from the GitHub from this. And then another kind of in-depth blog on using virtual partitioning. So we sort of we showed that there with the virtual partition on that large table, but this goes into some detail in the blog there. Okay, we'll jump to questions now, but I did want to thank everybody for joining today. And I hope that you saw that you may have become much more of a Redshift expert than you realized as you developed your expertise with Netezza. We look forward to working with you. Thanks.